All right, let's continue adding mixed numbers, but this time we're going to use unlike denominators. Now in this picture here, we've got a whole pie and then a half pie. And in this picture, we've got 2 whole pies and then a third of a pie. So 1.5 apple pies over here and 2 1/3 apple pies over here. Now the difference with this is that we've got a 2 in our denominator and a 3 in our denominator. So those are different denominators, so they're unlike. We can represent the pies using pattern blocks. And so instead of pies, we've got 1 whole and 1/2 pattern block. And then we've got 2 wholes and a third of a pattern block. So when adding these all together, let's group the wholes and the partials together. So we've got 1, 2, 3 whole hexagons. So we've got 1, 2, 3 whole hexagons drawn here. Now we've got 2 fractional parts as well. We've got a half hexagon and a 1/3 hexagon. So those are shown here. In order to add the half and the third, we need to use pattern blocks that are the same size so that we have a reference that we can use. Because right now, sure, we could add 2 pieces together, but that doesn't really tell us how much we have of the hexagon. If we break them down into triangles so that we've got a common reference point, we can actually start working with the numbers. So in this case, your trapezoid can be broken into 3 triangles, and your rhombus can be broken into 2 triangles. And the triangles are 1/6 of the hexagon. It's the same triangles we've been using all along. So these 3 triangles are all the same size as these 2 triangles. So in actual fact, instead of half, we have 1, 2, 3 out of a possible 6. And instead of a third, we've got 1, 2 out of a possible 6. So 3 6 for this one and 2 6 for this one. So now we've got the original 3 whole ones, the 3 whole hexagons, 1, 2, 3. And then we've got 1, 2, 3, 4, 5 triangles, and we can put them all together onto one hexagon sort of spacing. And so then we can see that we've got 5 of them here out of a possible 6. So when you add all of that together, you end up with 1, 2, 3, and 5, 6. So 3 and 5, 6. Now these pattern blocks are being used to represent the pies from the original question. So when we add the 2 different sets of pies together, we end up with 3 and 5, 6 pies in total. On the next page, we can do the same math, the 1.5 plus 2 1/3, but we can use an addition statement to do that instead of drawing pictures. Again, we can take our whole numbers and separate them out. So we've got a 1 and a 2, and then our fraction parts, 1/2 here and 1/3 here. The 1 plus 2 is the easy part. When we have fractions that have different denominators, we need to find a common denominator. To do that, we're going to take the multiples of those denominators and list them out. So for 2, we've got 2, 4, 6, then it goes on to 8, 10, 12, etc. And for 3, we've got 3, 6, 9, 12, 15, etc. Now, we can see that 6 is common in both lists. So we're going to use 6 as a common denominator. Now, in this particular case, it's a lowest common denominator. You could use numbers like 12 or 18 or 24. Those numbers will work, but your numbers are going to be a lot bigger to work with. So we prefer to go with the lowest common denominator, which is the lowest common multiple of 2 and 3. So we've picked 6. So we start, and as I do it, we say that we're wanting to find an equivalent fraction of 1/2 using 6 as our new denominator. To do that, draw it out this way. We say, okay, what's the relationship between 2 and 6? Well, we know that we can multiply by 3 to get 6 when you start with 2. If we do that on the bottom, we have to do that on the top as well. We're going to multiply by 3. Well, 1 times 3 is just 3. So that's the process you can go through to find 1/2 is equivalent to 3/6. Same process for 1/3. Let's find its equivalent fraction with 6 as a denominator. Here, we're not going to multiply it by 3 like we did on the other one. 3 times 2 will give you 6. So we do that on top as well. Multiply it by 2. In this case, 1 times 2 is 2. So 2/6 is equivalent to 1/3. Now that we have those equivalent fractions, we can substitute them in to our original addition statement. So we've got the 1 is here. We've got a 2 here and here. Those haven't changed. Now instead of 1/2, we're going to take its equivalent fraction, which we calculated to be 3/6. So we put that in here instead. Then instead of the 1/3, its equivalent fraction was 2/6. So we're going to put that in here. Now we can simplify it. We can add the whole numbers. 1 plus 2 is 3. And then we know how to add two fractions with a common denominator. We keep this same denominator of 6, and then we add the numerators, 3 and 2. So 3 plus 2 goes on top. You can take that one more step simpler, and we end up with 3 and 5/6. So 3 plus 2 is 5. So it becomes 5/6 plus 3. 3 and 5/6 is our final answer for that question. Now, you can use diagrams as well. We've got the 3 holes that we talked about, and we've got 3/6 shown here, plus 2/6. Now this is using the equivalent fractions. 3 plus 2 gives you 5 in total. So if you like diagrams and you just want to see it, you can draw them out and get to your answer that way.